So next couple talks, I don't have a great way to fit them into sort of a continuing running theme, a little bit more potpourri. But our next speaker is going to be Jared Stroud from Lacework. It's great to have Jared visiting us back at MITRE again. I mean, we've heard a lot about activity taking place the last few days in Windows and a bit of cloud. But we really struggled to gather the information that we needed to create attacks containers matrix. There's not a ton out there. And so when we saw Jared's proposal talking in this space, it was a really easy decision. So please help me welcome to the stage, Jared.
Hello, CatCon, how are we doing?
Is your mic on?
I hope so. And it is. So, my name is Jared Stroud. I am currently a security researcher at Lacework, specifically on Lacework Labs, the security research team. What that means is that we focus on all things container, Linux, and cloud threat related. So this kind of leads us into the next part of my talk of what we're going to be talking about today. So as you know, the pandemic's roared on and more people are working remote. We've also noticed the same shift of normal workloads from like on-prem data centers get moved to the cloud, and usually that ends up looking like containers. Now, depending on how this gets deployed, sometimes it's Docker, sometimes it's Kubernetes, sometimes it's a cloud-native resource. But we're going to talk about what that looks like from the point of view of the attacker and the point of view of the defender. Additionally, we're going to look at how we collected that data with some custom-built honeypots that we built. We'll analyze the data a little bit, and we'll leave off on some additional container-focused defenses that everyone can walk away with today to kind of improve the security posture of their organization a little bit. So, for those playing buzzword bingo at home, I've tweeted out a card, so please feel free to fill in the blanks as I go through some of the buzzwords here. But as enterprises shift left and adopt these DevOps tools to deploy whatever it is their product is to consumers faster, they're also taking on additional risk. As we take the Ansibles, Terraforms, etc. of the world and use those to scale, we can also misconfigure at scale. And this is where you get a lot of opportunistic attackers taking advantage of those gaps. For example, in October, we saw some pretty interesting things around GitLab with specifically remote code execution vulnerabilities. Opportunistic attackers saw this and leveraged that to deploy crypto miners, Mirai bots, etc. Now, the reason that I bring up GitLab specifically is because GitLab has a bunch of really interesting integrations into CI/CD deployments. So if I go to you and say, hey, bad news, it looks like your GitLab server got popped, you might have to go, oh, we also have GitLab runners that hit on these targets that deploy to our Kubernetes service, and then suddenly you have a bunch of additional things to dive down. So when we started seeing some of these attacks, they're also going back to the misconfiguration piece of just cloud service dashboards being exposed where they shouldn't be, or even just exposed APIs from the Docker container. We looked at how we can go about collecting this data better to dive into analysis. And this is where we kind of came up with building a honeypot. So when I say honeypot, just so we all have kind of the same nomenclature, talking about emulating a service to a specific level of fidelity so that we can go ahead and collect or trick an attacker to throwing their exploit, throwing their payload. We can collect it safely and analyze it. Now, I use a specific word here, level of fidelity. And this comes into conversation when you talk about the kind of data that you want to collect. For example, when Log4j came out, everyone was throwing that in their payloads and just spraying it across the internet. If you had a netcat listener on port 9200 or just port 80, etc., you're probably going to catch that opportunistic attack. If you're looking for something more targeted, then you've got to play a little bit more with how you're actually going to interact with those that are throwing payloads at you. And this is kind of where you start having the conversation of like, is this enough to trick an attacker that's really going to throw a payload at me? Or am I just looking for what's out there kind of spanning the internet? So Whale Honey, the Docker-focused honeypot that we built, works like this. Effectively, you have a container deployed that has the default port 2375, looks like an unsecured Docker socket. The attacker sees this, they throw their payload, and we emulate the Docker API based on the publicly available Docker API engine documentation. We take that data and we just throw it to a plain text flat file for you to do with it what you will. When we were doing the initial research, we saw a lot of honeypots were really heavily tied to specific databases. And when you look at like that from a researcher perspective, it goes, okay, now I got to deploy all this additional infrastructure. When really, if I just take that plain text file, I can then use it and enrich it however I want. So we wanted this to be super easy to, one, review, because at the end of the day, a honeypot is supposed to be deployed to emulate a vulnerable service, and you don't want to deploy additional risk in your infrastructure. But then two, ingest it with the tools that you use, that you're comfortable with, so that way you can do your research on your own. So some quick stats that we saw over running this for about a year now. We had 244 unique payloads targeting the API container create. Now, endpoint. Now, that endpoint, as the name implies, is for creating containers. So out of all of those, we only had 24 payloads with the privilege flag set to true. And if you're unfamiliar with that in regards to the Docker engine, what that does is eliminate some of the security settings that are typically in place with a Docker container that gets deployed. Effectively, it makes the container that gets deployed just like a normal process on the host machine. The other interesting thing we saw were 3 additional Sas services getting used regularly in some of these attacks. Docker Hub, to no surprise, for adversaries looking to stage capabilities. We saw ngrok, which is a reverse tunneling service that allows developers to expose locally, say, a dev instance that they're working on publicly to the internet. And then also WeWork Scope, which is a legitimate container orchestration and administration tool. Notably, ngrok was leveraged 146 times in different payloads. The interesting thing that we're seeing here with container-focused attacks and more things that are cloud native, for those playing buzzword bingo at home, is that we're moving from that same kind of living off the land attacks to living off the SaaS. These services that I've listed here are free or have free trials, and they don't cost anything for the attacker to set up. So just like they're making our lives easier, it's their lives easier as well when they don't have to think about infrastructure. Out of all of these attacks, the kill chain kind of breaks down into 3 separate ways. One, the attacker deploys a container, and they're going to go ahead and bring down a dropper script, which will then do nasty things. A staged container gets deployed, or the attacker tries to attach to bin bash in the container that's been deployed. For our honeypot, anything that was bin bash, we didn't care about. We wanted the payloads that were going to get dropped so that we could investigate. So now we're going to dive into what I thought was a pretty interesting post-X payload dropped by one of these containers. So this is a nice little JSON blob that our whale honey Docker honeypot will give you once someone's thrown a payload at it. If we look at the first red star, we see a command that first shroots to the mount directory. If we go ahead and jump down to the bottom red star, we see that this is a bind mount. So the underlying host's file system, the root file system, is being mounted into /mount, and then we're shrooting to that, effectively about to operate on the underlying host's file system. The next commands install curl and then set a cron job to go ahead and download and execute a specific file called cronb every minute or so. So what this is allowing the attackers to do is kind of have that host pivot from an exposed Docker API endpoint to then execute data on the host. And then this is where we see a shell script get brought into place that then brings down additional payloads. Of those payloads we see the first thing is that the purpose of a lot of these is to deploy cryptocurrency miners to monetize that initial access. So we see killing of other cryptocurrency miners because we don't want to introduce more noise into the environment. We see the own cryptocurrency miner getting deployed. And then for persistent mechanisms, we're actually seeing open source rootkits such as diamorphine getting deployed, some LD preload rootkits to hide some syscall interaction with listing contents of directories, as well as dropping SSH keys for persistence. As we dive into that a little bit more, the overall bash script was about 1,500 lines, and additional TTPs included killing cloud monitoring agents that are in specific clouds, such as Alibaba, where you see a utility called Alion getting killed, the additional SSH keys for continued access, diamorphine, as I just mentioned, etc. The 2 notable things that always we see with cryptojacking attacks, almost always, I should say, are a C2 agent getting deployed in the form of an IRC bot. And these utilities that I have listed here, Tsunami, Kaitin, or Ziggy Startux, they're all about the same with a little bit of differences in the code base. And the nice thing about these is that some researchers actually have the source code and they published to GitHub, so you can dive into it and actually see what the underlying source code looks like to see what your detections map to. The final thing that was executed by this bash script was a curl command to an attacker-controlled IP with a URI of ID check, along with the output of the ID command to see what the user ID was of this attack. So what this does from the attacker is a really lightweight way of saying, okay, I have user ID 0, root, on these hosts. I know my SSH key's been dropped. And if successful, those IRC bots should be calling back too. So we've established a bunch of different ways that we should still have access to these victim hosts. We're going to dive in a little bit more to those LD preload attacks. An interesting thing that we found is that a lot of the attackers that are focusing on container-focused attacks and the payloads we've researched are leveraging open source tooling. No shock there. But they're not doing almost any modification to the underlying code. So on the right here, we have Ghidra's pseudo decompilation output of the shared object. And on the left, we actually have the original source code from a utility called libprocesshider. What libprocesshider does is create a nice little bash script so that way you can quickly build shared objects that will hook specific syscalls and hide processes. To the right here, where you see process to filter on that strcomp function, if you were to double click that in Ghidra, it would take you to the string that it's filtering. In this case, it's XMRig, a very popular cryptocurrency mining utility. Similar with diamorphine, and if you're not familiar, also another open source utility that you can go and play with. Diamorphine rootkit offers some of the functionality that you would expect when someone says rootkit, kernel level rootkit. But the interesting thing here, if you've ever played around with the Linux kernel and building kernel modules, you have to build against a specific target. This bash script went ahead and installed the kernel headers and built the kernel module on target to then install it, introducing a bunch more artifacts that you could build into your detection routine. A final note here is kind of pivoting on strings. So maybe you're not a reverse engineer or someone that spends a whole lot of time in, say, Ghidra, IDA, etc. That's okay. The value that we're kind of trying to show here is just running strings on some of these executables and doing some quick Googles might result in better fidelity of finding out what this is, so that way you can make actionable next steps in your incident response plan. It's not going to happen all the time, but in some of the use cases that we've seen here, it's been really an interesting data point. So to kind of move on from that, a couple of the other interesting things that we've seen with just our data set of exposed Docker API are these drive-by compromises, if you will. So you have that exposed Docker API. We're going to go ahead and do, not pictured here, but that same kind of mount technique, and then just echo a public key into an authorized keys file, and then later scan the internet, try to log in. Nothing super crazy. And this is probably the most interesting one that we found recently, leveraging, again, a legitimate systems administration utility called Scope. And what this does is it deploys a Docker container in an environment with a specific service token that then calls back to Weaveworks' actual product. And that way you can log into a UI and then see all of the containers that you can orchestrate. So here, obviously, with that service token, you have a great point to pivot on in your environment and see, okay, where else is this deployed? Let's go ahead and hunt a little bit deeper to see where this is currently running. And again, probably to surprise of no one, Docker Hub being leveraged to, again, stage capabilities, masquerade as a potential Apache runtime with a vague username. But as we dived into the actual container itself, it was executing similar techniques that we saw earlier with curling an external payload, piping to bash, and performing those execution steps that we already discussed. To dive into the ngrok piece here, if familiar, ngrok will actually generate you for free a unique subdomain, so that way you can serve your web app. Well, again, this is costing nothing to the attackers, and they're leveraging, their own infrastructure at home, say like a VM. They have a little folder, they run ngrok out of there, and then suddenly they have a legitimate domain that they can then serve payloads from, take it down, and they didn't cost them anything. So things that we're going to talk about now are how do we improve our defenses and how do we actually stop these types of attacks and some of the more advanced defensive strategies. So out of the box, this is not news to anybody, but don't expose the Docker socket, right? No news there. Have strong ingress and egress rules. We've heard these things before. We understand them. But there's a couple of really interesting things if you're leveraging Docker in production called Docker Content Trust. And what Docker Content Trust will do is actually enforce digital signatures for runtime verification of the images in your environment. So this does introduce the overhead of having to do key management and all of those wonderful things that come along with it. But again, it'll stop that scenario where it's like, hey, this isn't signed by my organization. Don't run this. As we look at Kubernetes-based deployments, you can leverage administration controllers such as OPA, an open source policy agent, as the name says, to prevent pods from getting deployed from specific registries or without specific capabilities that might be risky to your environment. And if you're not familiar with what an administration controller is, effectively, it's another API your initial manifest will hit to be inspected to allow or deny. Think of it almost like SE Linux to a certain extent. Going forth into kind of the cloud native environment, depending on what you're using and what you're deploying, there may be tools already available for you to deploy signed images, so that way you can ensure that you're not deploying something that isn't meant to be in that environment. Specifically thinking of GKE's binary authorization, which makes sure that workloads are signed and it integrates with their key signing service, and AWS's EKS has image signing on their roadmap. Now, the final thing to have a conversation about is actually limiting the underlying syscalls that your application makes. Now, this takes a lot of time, and if you're iterating quickly, it can be kind of a little bit of whack-a-mole of ensuring that you're not breaking your application with this. But what it does is greatly reduce the underlying syscalls that your application can make, and it can be super powerful in terms of limiting what that rate of boom would look like in the event that you had a compromised container. Up until this point, we've really just talked about opportunistic attacks and some steps that you can take to limit that type of exposure. Let's say you're in the situation where you're looking to kind of improve those that have obtained keys and are maybe doing something a little bit manual in your AWS environment. Over at Lacework Labs, we did a little bit of research of leveraging Amazon Event Bridge, which allows us to define custom cloud trail patterns to look for, to then take action on. So this is an event-driven utility that once we see a specific action, do a thing. And in this case, we fired a Lambda function. Now that thing that we were looking for, in the case of the blog post that we have here, is a specific registry image that we had hosted in our ECR with an enticing name of, say, database secrets, something like that, to get someone to poke at our ECR image in the event keys were compromised and reconnaissance activity had taken place. That being said, you can leverage this same type of methodology to build detections in your own environment, kind of like Canary Token asks around, say, like S3 files or buckets, really any AWS resource. So with all that being said, just went through a bunch of stuff. We are releasing this today, so it is on GitHub at Lacework Lacework-dev/whalehoney-public, and pull requests welcome. It's just a pretty straightforward Python Flask app that allowed us to collect a bunch of really interesting data. And to just kind of quickly recap for the attack TTPs that we saw. We've seen containers get deployed to escape from host, with post-compromised payloads ending up as shell scripts, impairing defenses through those shell scripts of killing things like SE Linux and AppArmor, deploying keys for persistence, as well as LD preload hijacking, and installing kernel objects such as installing rootkits such as diamorphine. As we look to the right for defending, obviously you never get away from limiting that ingress-egress points, but also looking at enforcing signed container images and implementing security policies such as OPA to prevent specific type of deployments. And then you also have, finally, the proactive defense approach that we talked about with Honey tokens. So with that, we have reached the end of the presentation, and thank you all so much for letting me come talk about Kubernetes and containers.
And yet another tool drop. I promise we didn't plan that, we didn't ask for that, but it speaks a lot towards the community here and how willing you are to, everyone to kind of share and, like I said yesterday, not start from scratch. Really learn from each other's lessons and each other's tools. Excellent presentation. We have actually a lot of time for questions, so let's hear it. I'm gonna work on one of the biases I've been doing. I know I've been selecting up front. So anyone in the room, question for Jared? Okay, I will take the opportunity myself. I had a couple of interesting things. So I've, obviously big fan, been reading a lot of your threat research.
Thanks.
And, really from an enterprise perspective, what would be your advice in terms of, I think a lot of what you highlighted kind of, highlights the problem we have with, crypto jacking and kind of resource hijacking kind of in the attack framework.
Sure.
How would you, kind of recommend enterprises and organizations kind of fit that into their threat model? Like, is that something that's high priority, or how do you kind of prioritize and work into that?
That's a great point. So oftentimes when I've run into this, I think people kind of brush it away like, oh, it's just crypto jacking. So the way that I like to rephrase that is someone gained access to your environment, and then we just leave it open-ended. Then we go, okay, well, then what? Well, then they deployed this, but it could have led to something much worse, or perhaps it did, depending on the logs that are available. So I think overall, some people think of cryptojacking as just a monetary expense and don't understand the total impact that it can have on their underlying enterprise and bottom line.
Yeah, exactly, because it's not just like you said. It's a little minor here, a couple CPU cycles here and there.
Sure.
Impact, availability could be a loss of that system, but also as we see more adversaries go to that access brokering, in your experience, have you seen any of the overlap there of cryptojacker turns into a little bit more of a campaign?
So I don't have any evidence of direct linkage, but by all means, right? Like with some of the examples that we gave today, people are deploying remote access utilities, and then they want to monetize your infrastructure as much as they can. So let's start with the cryptojacking and see what happens. Yeah. I think it needs to be looked at more from that point of a strategic view.
Excellent. And one of the, I see a couple hands going up. I'll circle around in a second. Sorry, but I got a little bit of a thread here. So one of the things that I saw really resonated in your talk and connected to what Otis was talking about earlier was the importance as defenders to understand your system. You went through a lot of really, really deep technical ideas. What are recommendations that you have for organizations in terms of, I'm defending this is my surface area, this is my org. Sure. Like Otis said earlier, I need to understand this better than the adversary.
Absolutely. So there's a bunch of different ways to deploy containers in all of these cloud environments, on-prem, et cetera. Understanding how you're deploying those today, and then looking at what the defenses are around those utilities is going to be kind of a critical step one. And then step two kind of depends on however you have your current production applications getting deployed.
And please don't schmooball me or throw anything at me, but change management. I know that's a big one, kind of keeping track of the organization, but I saw a couple hands come up here.
And you actually led into this. Thank you. One thing that worries me all the time, and I always talk about what keeps me up at night. This is starting to as I'm moving more into this. With the the CI/CD pipelines. How do you start mapping that? Because I'm like a traditional endpoint defender. So
sure.
I can map my network. I can sort of map my endpoints. I can see things. But when I have code coming in as infrastructure, and now they're just being deployed here and there.
Sure.
How do you start mapping that?
So that's
sorry, one question, one sec. Repeating for the live audience, really great question. I really want you to dive into this. But as we start to look into orchestration and CI/CD, how do you map that, and how do you track that in the same way you would do traditional platforms or domains?
Absolutely. So there's a really good open source utility, or I should say like framework called Salsa, SLSA, and that kind of talks about mapping out your supply chain, which includes, how are you deploying tools, what does your CI/CD look like, and where does it end up? So kind of seeing where you go from, Git repo to production and following that thread, I think is super important. And then along the way, as you have these service accounts and API bindings, have those conversations of go, okay, if we had to, roll these API keys or roll these SSH keys, how easily can we do that today? And what happens if we have to do that? Who's the change management? Who has access to these things? Having those conversations today versus, in the war room when things are going on, will definitely avoid some headaches.
Another big one, you kind of caught me off guard. I was on your GitHub trying to read, and I was like, okay, I gotta get up here and take care of Jared. Looking at the Honeypot, that's tying back to the earlier conversation about Engage. I know you do a lot of really awesome projects and research in the space. What recommendations would you have for folks interested, looking at that GitHub and saying, how do I safely deploy this, and what are kind of getting back to that Engage talk? What are my goals, and how do I outline in doing this in a safe but also impactful way?
Great question. So when you talk about honeypots, there's always a conversation of never deploy something that you don't fully trust or don't fully understand. So in this case, we have it as simple as possible, basic Python Flask app that just logs the request as it comes in, do with it what you will. If you start looking at broader honeypot projects, there's a lot that have been around for a while, not updated. They use whatever version of specific database, and if you just go off deploying these things, you may be actually introducing more risk just like you would with any application that you're deploying. So you never get away from, this is still an application that I'm deploying in my environment. I need to know the left and right bounds and the specific security controls I have to have around this, and the open firewalls, ports, and all that great things. So especially with honeypots, if you're wrong, it's going to be a really bad day.
Very bad, yeah. So, and this is kind of, almost a personal question in a lot of ways. I've tried to read your blogs. After reading them a couple times, I'm like, there's just so much like information there.
Sure.
What would you recommend in terms of first steps in terms of learning the space? Because one of the themes of the day is like venturing into new domains and new spaces, like Kubernetes cloud.
Yeah.
Is it something where you need to really get hands-on and kind of feel it, or is there a process or a recommendation that you could share?
Absolutely. So the great thing about this industry is that there's a bunch of crazy things online to go forth and dive into. And it can be overwhelming for sure. The value of kind of spending, a couple hours at night or on a weekend or something exploring these things will just unlock so many opportunities. And specifically, personally speaking, I'm a big home lab fan. So if you see honeypots, you're interested in it, deploy one in a VM, poke at it, see what you can do. Big fans of that kind of approach.
Yeah. And one of the other things, I'm kind of nerding out here on Jared, sorry, but I appreciated the fact that in a lot of your blogs, it went from, you described your process, you described, how the kind of thoughts you went into work, the setup, this is how you would actually build this thing, all the way to Intel production. Any lessons learned and tips in terms of, really capturing, getting back to yesterday's big theme, that story in terms of, how kind of striking that balance. I think in your case, you have a very broad audience where, there's some folks that, I've even watching Twitter before, there are some folks that are like, pointing out ngrok and like little things, you have that like that reach, but also you did a really great job kind of, almost making it like a 101 where, hey, like, do this, like Johnny said yesterday, take risk, learn something. And by the end, in my experience personally, read it once. I was like, oh, there's a little stuff, a bunch of that's over my head. Read it again, a little more and a little more. What's your kind of take in terms of, striking that balance?
That's a great question. I don't think I have a great answer.
Yeah, yeah. Probably great.
Yeah. Starting small and kind of doing what you can with what you got, right? So, for this, some of the blogs we put out here, we focus pretty heavily on AWS. But by all means, if you're like a GCP shop or insert on-prem or whatever have you, look at how you can kind of like map some of those things. And that's an exercise in its own right of how you can go about getting similar data sources and diving into that.
Yeah, so really, really, yeah, I think it's always hard when you start research to know your goals and know your process. But like you said, like iterate and kind of capture that and tune that over time. Coming up on time here, but one final question, unless there's something you don't want to cut. Oh, sorry. Really interesting question. For the live audience, how do you feel about kind of that model of provider versus, I think it's called almost the dichotomy of you as the user versus the provider in terms of EULAs, terms of service. How does that really something you can exploit for security, or is it something that maybe a barrier, or is it a little bit of both?
So anything with a EULA, they have better lawyers than I do. So by all means, understand what those left and right bounds are and don't cross them, right? Specifically bringing up cloud providers and like pen tests. Obviously, there's specific left and right engagements around this. In this case, for what we did here, right, it was just listening on a specific port and incoming data just got logged to disk. Nothing super fancy about that. But by all means, if it's something that you're looking at deploying, definitely make sure that you've got all the things crossed with legal before you do that.
Shared security model. Just remembered it. Yeah, that was like Kat said earlier, vocabulary is very hard. Final question is, along that same vein, how, when you do kind of have, your hands up, there's only so much you can do as a user. What's your advice? I know it's probably come up in your space in working with the vendors. There's only especially with some of these vendors where you might not be, it's not open source.
Sure.
You had to talk to them. Is there any advice or any approaches that we can use to kind of, like you said, bridge that gap in terms of responsibility between user and,
Sure.
service provider?
At the end of the day, everyone's human. And, if you go to them like, hey, I got my problem, I was expecting A, I got B, just approaching it like you would like a conversation, just because it's over email, I don't think I'd treat it any differently. Yeah. So just approaching it in a normal fashion, like a conversation.
Lawyers are people too.
Lawyers are people too.
Thank you.